Let's graph y equals 1/2 sine of 2 theta. So the first thing we need to do is find the period. So the period will be found by taking 360 divided by the b value, which is 2. We will have a 180-degree period on this one. So part of doing these graphs is to figure out what a reasonable interval would be. So with a 180-degree period, let's go by 90s. And again, you could just choose to do whatever you want. So if I make every 3 blocks equal to 90, that makes every block equal to 30. One, 2, 3, 5, 40. Okay, that's pretty good. And with an a value of 1/2, that means the amplitude is only going to be 1/2 of a unit up and 1/2 of a unit down. So I'm just going to go by ones. So 1, 2, -1, -2. So every block is worth a quarter. And so remember that sine starts at 0, 0, and it will have to end at 0, 0. Or at the end of the period 0, so 180, 0. And then halfway between that would be 90. That's when it hits it again. And then halfway between those hits the high point and the low points. The high point is only going to be 1/2 and -1/2. So this is one full period here. And if I want to make a second period, I'll go to 360 and then hit the midpoint will be at 270. When it hits the x-axis again, the high point will be halfway between 180 and 270. The low point will be halfway between 270 and 360. So here is the second full period. And I can choose to do that as many times as I would like to. Sine and cosine functions can be used for anything that is repetitive waves, such as sound waves. Sound that has a frequency below the human range is known as infrasound. Elephants can hear sounds in the infrasound range with frequencies as low as 5 hertz per second, or 5 cycles per second. Find the period of the function that models the sound waves. So if it is 5 cycles per second, then the period is going to be how long does it take to go through one full cycle. So we can figure that out. If it's 5 cycles per second, then one cycle will be 1/5 of a second, because that's 1 divided by the 5 cycles per second, which we could change that to 0.2 if we wanted to change it to a decimal seconds. So that's part A. And then part B is to let the amplitude equal 1 unit, write a sine equation to represent the sound wave y as a function of time t, then graph the equation. Oftentimes, with these types of questions, they are not written in terms of degrees, but written in terms of pi. So the first thing we have to do is figure out what the period is. And, well, we actually already know what the period is. Remember, the period formula is equal to 360 divided by b. But if I want to change this in terms of pi, 360 degrees is 2 pi. So it would be 2 pi divided by the absolute value of b is the period. Now, normally we take the 2 pi or the 360 and we divide it by b to find the period. But in this case, we know the period. In part A, we said the period is 0.2 seconds. So I'm going to replace the period with 0.2 and set that equal to 2 pi divided by the absolute value of b. And we're actually trying to solve for b so we can write our equation. So to solve this for b, I would multiply both sides times b. So I would have b times 0.02 equals 2 pi, or 0.2b equals 2 pi. And then divided by 0.2, and 2 divided by 0.2 would equal 10 pi. So the b value in this equation is 10 pi. And part of the reason why doing this in terms of pi is that you'll wind up with numbers that are much smaller. If you try to do this in degrees, remember pi equals 180 degrees, so you would have 1800 in your equation, and 10 pi seems a lot more easier to work with, being a smaller number than the number 1800 in terms of degrees. So we know what the b value is now, and we are going to now write our equation. So remember, the sine function is y equals a sine of b theta. If the amplitude is 1, then our function is going to be y equals 1 sine, and our b value is 10 pi. So it would be sine of 10 pi. And we are doing this in terms of time, so 10 pi t. Instead of 10 pi theta, 10 pi t, because we're doing this in terms of time. So there's our equation. And then we got to try to graph this. So again, we know the period is 0.2 seconds. We've already figured out the period of being 0.2 seconds. So I'm going to write out, I will do every let's do every 5 blocks equals 0.2 of a second. So 0.2, 1, 2, let's make it every 4 blocks. You know what? Make it every 4 blocks, because that would make every block equal to 0.05 seconds. So that would be 0.2, 1, 2, 3, 1, 2, 3, 4 would be 0.4, 1, 2, 3, 4, 0.6, 1, 2, 3, 4, 0.8, 2, 3, 4 is 0.1. Okay, so that looks good. 0.1, actually not 0.1, it's 1.0. Okay, it also said to make the amplitude equal to just 1. So I just need 1 and -1. And then since we know the period is 2 seconds, this is going to be kind of like more accurate to what a sound wave looks like, because it goes up and down very rapidly. So I'll start at 0, and it will end the period at 0.2 seconds, reach that midpoint, reach the axis in the midpoint. Here's the high point, here's the low point. So this is 1 full period. And then it'll repeat again at 0.4 seconds if I want to draw another cycle. So here's a second period or second cycle, and so on and so forth. And I can choose to do this as many times as I want. And there is a sound wave representing the sound that an elephant can hear. Let's do another one that's very similar to that, because this one is talking about humans. Humans can hear sounds with frequency as low as 20 hertz, find the period of the function, and then let the amplitude equal 1 unit, write a cosine equation this time to model the sound waves, then graph the equation. So the period of this function is going to be, since it's 20 hertz, remember from the previous problem, that means 20 cycles per second. So in 1 second, in 1 cycle occurs in 1/20th of a second. That is the period. 1 cycle is 1/20th of a second. Then we're going to write in a cosine equation to model the sound waves. So since we know the period, we'll do period equals 2 pi divided by absolute value of b. So that'll be 1/20th equals 2 pi divided by the absolute value of b. So just like we did above, we'll multiply both sides times b. So that gives us b times 1/20th. Let's go and change that to a decimal. That's 0.05. So 0.05 b equals 2 pi divided by 0.05. And that means we're going to come up with 40 pi as our b value. So with a b value of 40 pi and doing a cosine function, we'll have y equals, the amplitude, as Sil said, is 1 unit, so that's the a value, so that'll be 1 cosine of 40 pi t. 40 pi t. So we already know what the period is, though. The period is 0.05 seconds. So let's make every block equal to 0.01 seconds. So I'll count every 5 blocks will be 0.05 seconds. So that's 0.05, 0.10, 1, 2, 3, 4, 5, 0.15, 1, 2, 3, 4, 5, 0.20, and so on. Since this is a cosine function, we will start at the high point. So the high point is at 1. It will end the period at 1 again. So the period is 0.05 seconds, so it'll end the period up there. Halfway between the high and the low points, or the period, will we reach the low point. Then halfway between there and there is where it hits the axis. So here's one full period. I'll round off my high and low points. And then if I wanted to write a second period, that's what the second cycle would look like. And a third cycle, whoops, not there, up here. And here's a third cycle. That point should not be there. And we can continue to do that with our cosine function.